Welcome to Ms. Math Presents Geometry SOL Prep G3 Coordinate Geometry. First, let's take a look at slope. The first thing we need to know is if slope is positive or negative. We read slope left to right, just like we do words. One way I like to think about it is thinking about it like your bank account. If it's going up, that's a good thing, that's positive. Now, if your bank account's going down, that's bad, that's negative. That helps me remember which way is positive and which way is negative for our slope. Finding slope using the graph, the first thing we do is figure out if it's positive or negative. Left to right, it's going down. And if this is my bank account, going down is bad, that's negative. Next step is to find two perfect points. Looks like we've got one here at 0, 5 and another here at 6, 1. From here, we're going to count along the grid lines. So my rise and my run. See, I can draw along the grid lines. I count going down 1, 2, 3, 4. So my rise is down 4, and my run 1, 2, 3, 4, 5, 6. So my run is 6. And then I'm going to simplify. I know that it's negative, and negative 4 over 6 in my calculator gives me negative 2/3. So we found our slope of negative 2/3. Next, let's look at our slope using our formula. So we had these same 2 points, 0, 5 and 6, 1. Our slope formula is y minus y over x minus x. So if I plug in my values from my 2 points, my y minus y is 5 minus 1, x minus x, 0 minus 6. In my calculator, this gives me back negative 2/3. So I still get the same answer whether I use the formula or whether I use the graph. Parallel and perpendicular slope. Parallel slope stays the same because they never intersect, then they have to have the same slope. For perpendicular slope, we do two things. We want to change the sign. So if it's positive, it becomes negative. Negative becomes positive. And then we flip the fraction. So let's take a look at some examples. If we have a slope of negative 2/3, our parallel slope stays the same, so it's negative 2/3. Perpendicular slope, we want to change the sign and flip the fraction. So my negative becomes positive, my fraction flips, and I get 3/2. If we have positive 3 over 7, a parallel slope stays the same. Perpendicular slope, I change the sign, positive becomes negative, flip the fraction, so it becomes negative 7 over 3. Now, example 3, 1/2. Parallel slope stays the same, easy peasy lemon squeezy. For perpendicular slope, positive becomes negative, and my fraction flips. Wait a minute, I've got negative 2 over 1. What does that give me? Oh yeah, that's the same thing as negative 2. So, don't let that flip you out. Anything over top of 1, it just stays that same number. So it's negative 2. So let's look at example 4. We have a negative 4, parallel slope, super easy, it stays the same. Perpendicular, change the sign and flip the fraction. Negative becomes positive. It's not a fraction, but negative 4 is the same thing as negative 4 over 1. So when I flip that, it becomes 1/4. Next up, let's find the midpoint of AB. We have given point A, 3, 3, and B, negative 5, negative 1. So we're going to do this two ways. First, I'm going to use my formula. My formula is endpoint plus endpoint, and then I take the result I get and divide by 2. So my endpoints, 3, 3, and negative 5, negative 1, I'm going to add those together. That gives me negative 2, 2. Then it's the midpoint. It's the halfway point, so I divide by 2. Negative 2 divided by 2 is negative 1. 2 divided by 2 is 1, so my midpoint is negative 1, 1. Next, let's find it on the graph. So, on my graph, I'm going to count along the grid lines from one point to the other. So, I'm going to go from point B over to point A, and then I'm going to count 1, 2, 3, 4 up, and I'm going to the right, 1, 2, 3, 4, 5, 6, 7, 8. So my midpoint is halfway, so I'm going to go up half of 4, and I'm going to go right half of 8. So up 1, 2, and right half of 8 is 4, 1, 2, 3, 4. And that gives me my midpoint at negative 1, 1. Exactly the same thing I found with my formula. So those are both ways to find our midpoint. If we're given our midpoint, to find the other endpoint, we've got both the formula and the graph on this one. So we have 2 points. We have the midpoint, negative 1, 1, as the midpoint of AB, and we have point A, negative 6, 3. So our formula is the opposite of what we did before. Before, we added the endpoints, and then we divided by 2. So this time, we're going to multiply the midpoint by 2 and subtract the other endpoint. So my midpoint is negative 1, 1. So 2 times negative 1 is negative 2. 2 times 1 is 2. So negative 2, 2 is what I have when I double my midpoint. Then I subtract my endpoint, negative 6, 3. And I get 2 minus negative 6 is 4. 2 minus 3 is negative 1. So 4, negative 1 should be my other endpoint. Let's look at this on the graph. We're going to count along the grid lines just like we did before. We're going down 2, and we're going to go over 5, and then we just repeat that same thing. So down 2, over 5 again, and we get our other endpoint at 4, negative 1. Okay, now when you see the words distance, length, how far between 2 points, we have 2 points, A and B, so we're going to plot them on our graph first. The next thing is we're going to draw a right triangle. We're going to follow the grid lines, and then we're going to draw our diagonal. Then we count the lengths of each leg. Legs meaning the ones that go along the grid lines. So this side is 6, across is 8. Then we're going to use our Pythagorean theorem, a squared plus b squared equals c squared, to solve for c. So our diagonal is always c, that's our hypotenuse. The other 2 sides are a and b. So 6 squared plus 8 squared equals x squared. When we solve for x, we get that x is 10. So our length between AB, or AB, is 10. Thank you for watching Ms. Math Presents Geometry SOL Prep G3 Coordinate Geometry. Keep studying. See you next time.